Uh, oh, that's so dumb. Why are these two separate steps? Okay. Sorry, folks. Online. Okay, we're live now. Yep. Nah, thank you. Sorry. Cool, thank you. I'm sorry I wasn't watching the chat. I thought I had it on the screen, but I have too much stuff on the screen. Give me a second here. I will fix things such that I shouldn't miss the chat again. Okay. So the only main things that you missed was me explaining these words and the agenda. The slides are shared in the Saturday Hangouts channel, so you can go there to catch up if you need. I will try to watch chat better, um, so if you have questions. Cool, thank you, Jay. Jay will help me too. I'm so happy I'm not doing this alone anymore. Okay. So collaboration. These source control systems were specifically designed to help teams work together on the same code. Because without a proper system to help manage that, it can be a nightmare. I've done it. It's not fun. I was in a 48-hour game jam where you get a whole bunch of people together to build a game in 2 days, and we didn't know what source control was, and we tried to merge all of our code in the last 2 hours, and we failed miserably. So use source control, avoid those kinds of problems. Um, and the nice part is when you try to merge these changes, usually source control systems help you intelligently merge the code. They can identify what is and isn't okay to merge. And if for some reason they can't figure out how to merge changes, they'll say, hey, wait, there's a conflict. I don't know how to handle it. Okay, and we'll go over that in a bit. And then lastly, safety. Source control, usually you have a separate copy of your code on a server somewhere so that if you're, you know, if you accidentally delete a file, no problem, it's on the server. Your notebook fell into a trash compactor, no problem. Or like in my case, one time, someone breaks into your grandparents' home when you're on vacation and steals your notebook, no problem. Except I didn't actually use source control back then, and I lost my whole audio project. But anyway, um, so source control is good. Use source control. Don't have the same horror stories happen to you that happened to me. Questions about this so far? Yeah. So what file? You mean the presentation? Yeah. So in the Saturday Hangouts channel. Yeah. Cool. Other questions? Also, we're still like all this doing live stuff is kind of new to us, so I apologize for the bumpiness. We're getting better as we go. Promise it'll be better next time. All right, going forward. So given that that's source control in general, what is Git? So first off, Git is the most popular version of source control. There are other alternatives that I'll talk about in a second, but Git is by far the most popular. To the point where like if you're like I'm a software engineer and then someone says like so you know Git and you're like what? They're like you're not a software engineer. Now that's not true 100% of the time. For example, I have a friend who works at Google who's hyper specialized in his area, and he has no idea what Git is, but that's because he's like super specialized. So there are exceptions to everything, but your average engineer uses Git every day, many times a day. Okay. Big thing is that it's fully distributed. So each copy of the source code um, is a complete copy. Okay. So if for some reason the server that you're storing your code on blows up, no problem. Your local copy is a complete copy. When the server is repaired, you can just push your copy back up and everything is cool. Um, it's also the easiest alternative, in my opinion. There are others like Subversion, also called SVN, or Concurrent Version System, CVS, but those are very old and very few people use those anymore. Um, there is another alternative called Salesforce, which is quite popular. I know of several video game companies that use Salesforce, but it's very different, and that's only going to be at very large companies. Most companies still use Git. And it's also a command line utility, which is great because when you're working with command line utilities, you can do automation. Now, granted, most things with Git are more human driven, like it's a decision by a human, and then Git is how you make that decision happen. For example, making a checkpoint, only a human can do that, really. But there are other things like hooks, where you can trigger different behaviors in response to things in Git. Okay, so does that all make sense so far about kind of what Git is, or the nature of Git? Cool. All right. So let's get into Git concepts. What are the different parts of Git that you need to understand in order to use it properly? Um, so first off is the idea of a repository. A repository more or less corresponds to a software project. Okay. Now there are some companies and organizations that put multiple projects into one repository, but for most cases, one repository is one project. Period. Um, and then a project belongs in one folder. Okay, so you have kind of a root folder where maybe all the other stuff within the project is inside, but the repository is that folder. Okay, um, and everything in that folder is tracked as part of that repository, with some exceptions. You can configure some stuff. We'll talk about that in a little bit. And then history. What I mentioned that the big thing about source control is history. History is tracked at the repository level. Okay, so you can dive into the history of individual files, but the history for the whole repository is tracked. All right. Um, Next is commits. Commits belong to a repository, and a commit is a checkpoint in time of the state of the files in the repository. Okay, so if you have all of your files in your software project and you make a commit, right, it takes a snapshot and then it puts it somewhere nice and safe. Okay, and then later you can go back to that commit if you need to. Commits are how we create history. All right, a commit consists of a hash value, which is just a whole bunch of letters and numbers, to identify the commit. It's like a big long ID. Okay, the files that were changed and what changes were made, a message that should describe the changes, which you have to decide when creating a commit, and a timestamp when the commit happened, and information about the author. So like their name, maybe their email. Remember we were talking about accountability, so you can see who made what changes. Commits are how you do that. Okay, so far so good? Cool. And then branches. I mentioned that you can do experimentation and all this kind of stuff. Branches are usually how you do that. A branch, so a repository has a line of history, right? And a branch is an alternate path of history. So you can say, hey, I'm going to make these commits, and now we can have two lines of history going forward. That's very common. That's a normal workflow in Git, to make a new branch and then do your work on that branch. Now, commits also belong to a branch, okay? So we have, I probably should have written this in a different order, but you have a repository, consists of branches, consists of commits, okay? Now, the main reason for branches, that alternate history, allows you to have multiple versions of a repository while being kind of equal in time, okay? So they can progress concurrently. Now, one thing is that the history for branches will diverge, right? They'll make new history, new commits on each branch, but they must at some point have a shared history, a shared trunk, okay? Does that make sense? I see less head nodding. So a repository tracks its whole history, right? And then I can't have a branch before the repository starts, right? I have to have some kind of history and then I can make a branch. And the history before that branch is made is the shared history. Okay, that's all it is. Okay. So good on branches? Cool. Now I know we're going through this quickly. We're going to reinforce this once we get to the hands-on section. Okay. And then remotes. I said earlier that your local copy of the repository is a complete copy. Well, if there's another copy somewhere else, you can tell your copy that that other copy somewhere else exists. I'll get to that question in just a second. And to make the relationship between your local copy and that other copy, we say it's a remote copy. It's in a different location. So we just call it a remote. Okay. So a remote is how if you have your code stored, if you have your source control repository on some server and on your local notebook can say, hey, the server is a remote copy, and then they can talk to each other back and forth. You can fetch new history from the server. You can push your history to the server, all this kind of stuff. Yeah, so we had a question online. What is a shared trunk? So I mentioned, I think I mentioned this earlier, but I'll repeat it again, maybe a little differently. When you create a repository and you create commits, you're building history, okay? We call kind of the main history the trunk. It's just a metaphor. We talk about trunk and branches. You know, if you think of a tree, the main part is the trunk, and then the branches are kind of different pieces. It's the same idea. The main history, the kind of core of the organism, the core of the tree, is the trunk, and then the branches are kind of alternatives. Does that make sense? Right, streaming is a little bit slow, so the answer is going to be delayed. But all right, I'll assume yes. If it's not clear, just ask a follow-up question and I'll answer it. But yeah, going back to remotes, a remote you have another copy of the repository elsewhere, and you can say, hey, I know about you, and we can push and pull history between each other. And then tags can be applied. So usually with commits, we identify them with that hash, which is just a whole bunch of random numbers and letters, and like a 64 character set of numbers and letters, you're not going to remember that, right? So if you want to reference a specific commit in history, like you're kind of screwed, right? Tags allow you to kind of name a commit. It's not exactly what's happening, but it's a oh, I think yeah, main is the trunk. Yes. Um, so tags allow you to kind of apply a name to a commit along with a message. So for example, you have a whole bunch of commits building your software, and then at some point you're like, okay, this software is ready for release. I want to note that this commit is when I released it. Well, then I can add a tag that says, hey, this is version 1.0.0, right? And then I can mark that tag. I know this is when I released it. This is the version of software that's out there, and everything's good. The history is clearer. Okay, so that's mostly what tags are used for. Does that make sense? Questions about repositories, commits, branches, remotes, or tags so far? Yeah, yeah. So the question is, gotcha. So the question is, when he's been working with Git things, he's seen main and master. Um, when you make a repository, you have a default branch when that repository is made. Because everything has to be in some branch, although one branch is the trunk, the main history, right? Um, in the past, that original branch, that default branch, was called master, the master branch, the kind of root of all the branches, right? But due to certain feelings around the word master, people wanted to not use master anymore, so they renamed it to main. So older versions of Git, like I'm on an older version of Git because I'm just too lazy to update, will start with the default branch as master. Some newer versions, I think, have the default branch as main. Functionally, they're the same. Um, Different some repositories may not have switched to main. Most have. Um, it's just the name of the default branch. Does that answer your question? Yeah. What's up? Yeah. 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 So for folks online, we had a comment. We changed from we wanted to get away from the words like master and slave because of the kind of historical implications, and we wanted to not think about things that way. So thank you. Cool. Any other questions? Yeah. So tags can be applied to any commit anywhere. Usually, in practice, tags are only applied to commits in either a release branch, if you're doing like crazy Git flow stuff, which we're not covering today, or on your main branch, depending on your team's workflow. Um, Doing tags on like feature branches or experimental branches is not very common. You can do it. There's nothing stopping you, but it's not very common. Does that answer your question? Ah, can one tag belong to two different commits? I actually don't know. I want to say no, but I haven't tested. To me, it doesn't make sense to. But we can, when we get, we're going to cover tags. When we get there, we can do a little experiment and see if it works. I anticipate it won't work, but yeah, cool. Other questions? That's a good one. We're gonna figure that out in a bit. All right, so let's so that's enough theory. Okay, everyone's got their notebooks out. Everyone's good to go. Git's installed. You have a GitHub account. Okay, cool. So let's make our first repository. Okay. Um, so make a directory or folder somewhere. Okay. This folder will be where your project will live. All right, and this will be where we will set up our repository. Okay. So somewhere on your notebook, make a folder. I will do that right now. Where is why? Where? There we go. Um, oh, two more questions. Ah, so the question was, I'm not sure if I heard correctly. Correct me if I am wrong. I think I heard you saying that in Git, if server breaks down, you're still able to retrieve your code. If that is the case, if they do have two servers with replicate code, so one can back it up. Um, I may not have been clear. With Git, each copy of a repository is a complete copy. So if you have copied the repository from the server to your local computer and something happens to that server, you still have a complete copy on your local computer. Your local computer is the same kind of value and importance and data as what would be on the server. So if once the server gets fixed, you can just push your repository back to the server and it'll be the same. Assuming that the server copy and your copy were in sync at the time of the crash. Um, so two servers with replicate code so one can back it up. You could do that with Git, but it's better to just do disk backups of your server. That's just a better idea. Now that's not to say that you should not back up your source control server. You should absolutely back up your source control server, because you can't guarantee that everyone will have a local copy. But if for some reason there is some extreme problem case, you can probably be okay. So I hope that answers your question. If it doesn't, again, ask a clarifying question and I'll answer. All right, so go ahead and make a folder. So I have, which one do I want to use? Actually, wait, hold up. We got, I'm having trouble seeing here. Raise your hand if you have a Mac. Okay, so raise your hand if you have Windows. Half and half. Man, come on. Okay. I'll just do both. Okay. True, but I don't want to confuse them with, well, it's going to confuse them either way. We'll try it. I'll do it on both anyway. So I'm going to go to I have a project folder on Windows and I have a project folder on my Linux machine, which is close enough to Mac. Follow-up question. So one in local computer and one is other in the server. Yes, that is correct. Basically, my point was that the server copy and your local copy are of equal importance. The Git system doesn't think one copy is more important or more special than any other copy. That was mostly my point. So I'm going to make a new project folder here. I don't know Windows 11. Okay, so I'm gonna do like, what is it? 2023 intro Git. Okay, so I made this folder here. We'll do it here too. 2023 intro Git. Cool. All right. So I'm gonna go in this folder. Okay, this is gonna be my project folder. Okay, there's nothing in it, but I have this project folder now. And so once you've done that, open a terminal or command prompt in that directory. We can help you if you need that. So, oh man, I don't know if Windows 11 has this. We're gonna find out. So in the case of Windows, yes. Oh no, terminal's not installed by default. Oh no. Okay, what you can do is if you're on Windows and you don't know command line, you can hit the Windows key and you can say command prompt. Okay, you get this. You get this big, scary black and white screen. I promise it's not as scary as you think it might be. Now I have to do a special thing because I have weird partitioning on my computer. But then you can just click this bar up top here. This gives you a folder path. You can copy this. And then you can say CD, which is short for change directory, space, and then right click to paste. And now our command line is in that directory. Okay. Now, there are ways to do Git with like a graphical user interface. I'm not teaching you that today. I'm teaching you the command line version. I'm not saying one is better than the other. Personally, I prefer command line. There are plenty of perfectly excellent engineers who prefer the graphical interface. It really doesn't matter. I'm teaching you this because it's a little, honestly, because it's a little harder. And if you can do it this way, you can do it with a graphical interface. Okay? So the preference is yours, but that's what we're going with today. And then on Mac, you can do a similar thing, but I don't have a Mac UI here. But Jay and I can help you get set up on a Mac if you need. But to simulate a Mac command line, I will just set up a Windows subsystem for Linux folder, and I will do, oh no, the backslashes, Windows, why? Why did they bother to change that? All right, I'll just, oops, CD projects and 2023 intro Git. Cool. Great, okay. So I have Windows, I have Linux. Linux can be for Mac people, Windows can be for Windows people. All right, so once you have your folder, once you're, are Mac folks, are you able to get your command prompt into the right directory, or do you need help? Mac folks are good? Mac folks are good, okay. If you have troubles, raise your hand. Cool, glad you got it online. All right, so now we can do the magic. Let's go ahead and do git init. Actually, this is probably tiny. Let me make this bigger so you folks can see. There we go, how's that? So you can do git init, okay? If you do that, you'll see initialized empty repository in whatever folder, okay? Everyone should see that. Git init is not complex. Make sure you spelled it correctly. But if you have done this, congratulations, you've made your first repository. Wasn't that hard, right? Except for maybe the command line part. That can be a little scary for people. Okay. So once you've done this, you've created a repository that will have its own history and all this kind of fancy stuff. Now, this is none of the, hold up, just answering a message here. Sorry, multitasking is hard. All right, where am I? Okay. So now kind of a preview of more advanced things. If you're like, but wait, how does Git like know it's a repository? It makes a hidden folder .git, but don't mess around in there. You can break stuff for your repository, but that's how the magic happens. There is no magic. But it's usually a hidden folder, so that's why you may not see anything. So now that everyone has their repository created, yes? cool. Nods. Excellent. How are we doing on time? Not bad. All right. So now we can check the state of the repository. Okay. You'll notice that we're doing git space something. Okay. Git has a bunch of subcommands, and we're just gonna go through a bunch of these subcommands so that you can get familiar. So you can do git status, and it will show you the state of the repository, right? Like, are you up to date? What files have been changed? All this kind of stuff. So go ahead and type in git status right now. So if we do git status, you'll see we're on branch master. Again, I'm using an old version of Git. The new way of things is main. Yours might say main depending on which version of Git you have installed. I should really update. I just am too lazy. You see no commits yet, nothing to commit. All good, right? So now what we can do, let's go ahead and have way too many windows open. And let's make a new file. So I'm just going to make a new file here. Can I get a txt? Yeah, there we go. My file.txt, and I'll do the same here. Ah. I cannot see on this tiny screen. Okay. Actually, I wonder if I do Control plus here, does it work? Of course not. Okay. Anyway. So now I have a file. Okay. If I do git status now, and I'll do it on both Windows and Linux, you'll see, hey, still no commits, but I recognize that there's a file in this repository folder, and I'm not tracking it. Okay. Git will only record history for files that you tell it to record history for. Okay. And we just made a file. We haven't done anything with Git yet. We haven't told Git that we want to track it. Okay. Oh, okay. Too many windows. Okay. So cool. So we have our file. Git recognizes our file. That's cool. But now let's track the file. Okay. So Git has another subcommand called add, and add will either track a new file, or if a file already being tracked has changed, it will add the changes to that file for the next commit, which we'll talk about in a minute. So go ahead and do git add and then the name of the file you created. Okay. And then once you've done that, do git status, and you'll see something change. So do that on your machine, and then I'll do it up here. I'm only going to wait a few seconds because it doesn't take too long to type. So I'll do git add myfile.txt. Now here's the thing. You'll notice when you hit enter, nothing happens, right? Git follows the kind of Linux philosophy of if everything is cool, be quiet. When things are broken, then be loud. Okay, so when you do git add and you don't see anything, that means it worked. If there was a problem, it'll print out some kind of error message. So now if we do git status, you'll see, hey, it was red text, now it's green text. Yay! So instead of being an untracked file, okay, now it's a change to be committed. Okay, so we said, hey, Git, I'm planning on making a new commit, a new checkpoint, and I want to include this file when I do that. That is what we have done by saying git add. All right, does it make sense? Cool. So now we've made a repository. We've made a new file. Let's make our first commit. Whoop. Yeah. So do you remember what a commit is? Do you remember the parts of a commit? Can anyone call out what a commit consists of, if they remember? This is why I don't teach in schools. Participation is tough. So remember the git hash? Yep. Timestamp. Any others? Username or author? Yeah. Message. The file's Yeah, the file's being changed. Yeah. Now, I'm not sure if that's what you would find in a textbook, but that's how I think about it. So now when we create a commit, it's going to ask for our author info. So what I recommend doing is set your author info now. You can set it for Git as a whole, so you never have to worry about it again. So if you just run these two commands to configure your global username and global user email for Git, Git will just remember those and you'll never have to worry about it again. Again, if you do it correctly, it'll be quiet. You won't see any output. If there is some kind of problem, it will complain at you. So go ahead and run these two commands with your information. Do be aware that if you actually pause for a moment if you're typing, please. I want to highlight an important point. Whatever you enter here, if you push to GitHub, that information is public. Okay? So if you don't want your legal name to be public, put some bogus name or a nickname or something, okay? And use an email that you don't mind being public. Okay? Just trying to make sure we cover people's privacy here. And then once you've done that, please give me a thumbs up. You need help? Jay, can you help her out? Thank you, dude. Man, I'm so glad Jay is here. Uh-oh. Oh boy. Okay. Oh, why am I right? That's why. Do you need reinforcements, Jay? Her documents folder or something? Yeah. Oh, that always happens every time I teach this class. That's why I tried to make a folder together. Okay. Yeah, blow up the repo. Yeah. So, this is worth mentioning online. This happens every time I run this class. Because we've done this class like 5 or 6 times. A lot of people, when they make their first Git repository, they're in their My Documents folder. And so that to Git, that's like, oh, you want me to track your entire documents folder? Like, no, that's not what you want. Make a folder for your project. Go into that folder. Git init in that folder. That project folder should be your Git repository. If you made this mistake, don't feel bad. Someone makes it every time. It happens. If you have done this and you want to undo it, I'm going to tell you the nuclear option. Do be careful when doing this, but remember when I was talking earlier about fancy stuff? So you have to, on Windows, you have to enable hidden files. It's in your Explorer settings. On Mac, you can do Command-Shift-period. That will show hidden files. If you want to just blow up a repository, you can just delete this .git folder. Now, don't do that lightly, okay? Because if you do it in the wrong project folder, your entire Git history is gone. Okay, so don't mess up when you do this. Make sure you're deleting the right stuff. What's up? Yeah. I'm gonna help. I'm gonna help him real quick. So I'll be right back. Whoa, let's not have metal ping sounds going through the mic. Yeah, what's up, dude? Cool. All right, folks, thank you for your patience. Context. What is the context we're in? Right, okay. Thank you, Jay, for helping out. So now that you have configured your global stuff, now that Git knows who you are as an author, again, adjust your information if you're worried about privacy. Let's go ahead and make our first commit. So you've added the file to tracking. Let's make a checkpoint. Let's make a point in history for this repository. So you can do git commit. Now you can just type git commit, but then it'll open Vim or something. And if you're here, you probably don't know Vim. And then you're going to panic and you'll be like, what happened to my terminal? How do I get out of here? Don't worry about that. I'll talk about it more in a second. But do git commit space dash M. M is short for message, okay? And then in quotes, write some kind of meaningful message to describe the changes that you made. Because this is, you're literally writing history with these commit messages. So if you're working on a team, when other engineers look through the history, the more accurate and concise you can make your commit message, like informative but small, the easier it is for them to find what they're looking for when they're looking through history, okay? This is very important. Don't be like changed things. Like your first manager will like smack you upside the head if you do that. Hopefully not, because that's abuse, but like, don't do that. All right. So once you've done that, you should see probably nothing, because again, when things work, it's quiet. So let's do git commit added test file, or added file for committing, which is not super descriptive, but we'll go with it. Okay. Okay, no, it is a little bit noisy. So it tells you, hey, we're on the master branch. This is the root commit. Here's the short commit hash. There's a short version and a long version. Okay. Here's the commit message. Here are the changes, or the total number of changes, and here is what changed, the file that changed. Okay. Does that make sense? Everyone sees something like this? Cool. This is going way smoother than past times. I'm loving this. We'll do it here too. All right. So congratulations on your first commit. All right. So you've written your first history. So we make a big deal about, writing history, being able to go through history, all this kind of stuff, but how do you do that? So, oh, right, sorry. The M part. So if you write this, if you do just git commit and then you hit enter, let me just do this real quick. So let me do, don't follow along with this. Let's say I do git commit and I don't do the dash M. You're going to get something like this. Actually, not quite this, because my Vim is configured funky. But you're going to see this and you're going to be like, oh my God, what is happening? What is on my screen? What do I do? And then you're going to try to hit escape a bunch of times and nothing's going to happen. And you're going to be like, how do I get out of here? I just wanted to commit. This is a text editor called Vim. Okay. Clicking does not work. There's no clicking here. We are on the command line. If this happens, just hit this is going to be hard to remember, but Control Q exclamation point will get you out of here, okay? And that will cancel the commit, and then you can do it with the dash M. Now, Vim is great. This text editor that we were just in, Vim, it's wonderful. I love it, but we're not going to teach you Vim in this class. It's way too much. Now, in I linked to a good Vim tutorial in the slides. So if you do want to go learn Vim in case that happens and you don't want it to like cause you trouble, you can do that. Vim is cool. I love it. I do recommend it, but we're focusing on Git right now. Okay. So that's a thing. If you forget the dash M and Vim comes up, don't panic. Search for Vim. Search for how to get out of Vim. You'll be okay. All good? Cool. What's up? I don't remember. Let's find out. I don't know how to touch on Windows. Windows has echo? Yeah, I just want to write a file. Really? Oh, does that work? Nice. Thank you. I didn't know that. So I guess it set up Vim on Windows. Yeah, so same thing. Colon, Q, bang. Yeah, no, good question. Cool. All right, so enough of that. So we going back to before I forgot what the next slide was. How do you look at the history? Well, you can look at the log. If English is not your first language and you're like, what does wood, what does a tree have to do with with history? Um, log also means to like record history as a sequence of events. So that's where the term comes from. So we can do git log, and then you can see the long version of the commit hash, along with what branch it's on. You can see the author information. Yeah, my info is all online anyway, so I don't care. You can see a timestamp, and then you can see the commit message. Okay, so this is what the history looks like. Usually you'll look at history on GitHub or in some development environment, but this is an alternative. Okay, questions about the log? Cool. Now there is all sorts of cool fancy stuff you can do with the log. You can actually search through the log, you can change the output and all that sort of stuff, but that's way out of scope for this. But that's where like Git being a command line utility is nice because you can do all kinds of text-based automation, but we're not covering that today. So now that you've done your first commit and you've checked your history, you can see the result of that commit. Let's go ahead and work with branches. Remember, branches are an alternate history, okay? So let's start experimenting with that. So check your branches. Git has a subcommand called branch. So if you type git branch, it will show you what branches exist for this repository, including your main branch or master branch, again, depending on your Git version. I should really update. So if we do git branch, okay, now you can see that mine just prints out master here. Again, I'm on a very old version of Git. And I forget what the color and the star mean. I think the star means that it's the current branch you're on, or maybe it's the color. I don't remember which, but if you have multiple branches, it'll be pretty clear which is the branch you're currently on, okay? And when you do git branch, it'll list all of your local branches, okay? So again, a branch is an alternate path of history, okay, with its own set of commits from the point when the branch is created, okay? So let's go ahead and make a new branch. There's another command called checkout. Checkout actually does a whole bunch of stuff. And checkout is not the only way to make a branch. You can just type git branch and then the name of the branch. But if you do this command instead, it'll create the new branch and you'll automatically switch to that branch. So why write two commands when you can just write one? So let's go ahead and do that. So I'm going to do git checkout -b. The -b part is what makes the new branch. And I'm going to say my branch. Okay, so you'll see it says switch to a new branch, my branch. Okay. And then if you do git branch again, you'll see that now we see the master branch and my branch is highlighted as the current branch. Okay, make sense? Cool. Nothing fancy there. Now, let's go ahead and change the file and make a new commit. Okay? Let's see if you can remember how to do that on your own. So I'll give everyone a minute to try that. So add some new text in your txt file or whatever, or maybe make a new file, make some kind of change, add the change, and make a commit. Let's see how much you remember. If you can't remember, you get stuck, you can just wait a moment, because after you guys try it for a couple minutes, then I'll do it and you can follow along. We're doing good on time. Ooh, excellent. If you manage to make a new commit, give me some kind of signal so I know you're good. Wait another 1 or 2 minutes for people. I should have brought one of the chairs in here. What's up? Sorry, one more time? No. So we had a question of, is making a new branch making a new commit? No, it is not. A branch is not a checkpoint in time. How can I describe it in a way that makes it clearer for the contrast? You can think of a branch as a separate category of commits. So I kept saying that a branch is a divergent history. So basically, when you have a history, it's a connection of one event to another event, right? So I went from commit A to commit B to commit C to commit D, right? But with a branch, you can say, I have commit A, right? And then I can branch off. And up here, I can have commit B. So A is here, A is my thumb, B is my index finger, right? And then I can say, hey, maybe I have commit C here. And so both the main branch and my new branch share commit A. It's a shared history, right? But maybe I make a new commit on the main branch and then a different new commit on the new branch. And so these are two independent histories now. Okay, so a branch just really creates a new path for history to traverse. Does that make some sense? So let me actually pull up an image for you real quick. Sorry? Yeah. So for example, yeah. So why did they draw it back? What? What is this backwards nonsense? Okay, imagine all the arrows in the opposite direction. But actually, no, this is weird. Let me find a different one. That's just no. Yeah. Yeah, why not? Let's do this one. So like, oh, this is hand drawn, whatever. So like, let's say that this one right here is your origin, right? Your first commit. Then you can make a branch over here, and then when you make a new commit, it's on this path of history, right? But then maybe let's say you stay on this branch and you make another commit, that's a different path of history, right? And so you can have all these different paths of history, and the branch just kind of determines which commits are related to each other and which are not. Does that make sense? Yeah, so he said it's kind of like a road. Yeah, I would say that's pretty accurate. Does that make sense? Yeah, a commit is a node. Yes. So if you get into the computer sciencey side of things, Git is really just a fancy graph manager. Like this is just a graph of history, right? Where each node is a node in the graph. and you can think of the history between nodes as the edges, right? Or kind of the branch as like a sequence of edges. Does that make sense? Cool. Yeah. All right, so is anyone still... All right, at this point, you've probably had enough time to make your first commit if you were able to figure it out. If not, you can follow along and I can walk you through it. So, we wanted to make another change. So I'm going to pull up my folders again. At this time, maybe I'll just edit the file directly. Open, I guess, Notepad. New text in my file. Make this bigger so you can see. Okay, so I'm just editing the file, save. Okay, let's do that with this one too. Actually, let's delete this because, yep, cool. So open. Dogs are cool. I don't know. Okay. So I've made changes in my files. Okay, so if I do git status, I can see it recognizes that, oh, I did add that. Oops. Whatever. Oh, I didn't delete other file. And Windows doesn't automatically update because it's cool. Sorry, the other file was from the thing I was demonstrating earlier. You won't have that, please ignore. Wait, I made a commit? What? Oh, that's why. Why? Okay, whatever. Anyway, so I have my changes, right? So I can do git add. Now here's a cool thing. If you do change multiple files, you have a couple of options. You can either list each file by name, and you can just keep adding file names. So you can do that. Or if you know for absolutely sure that you want to track every change in the directory, you can do -A. Do be careful with that, otherwise you may add files that you don't intend to add. So be careful, but you can do that. So now I do git status. Here's my modified file. That makes much more sense. And then I can do git commit m demonstrating modified file. Okay. So, yep. And I'm on my branch. I'm not on master. So if I hit enter, I've made a new commit. Let's do the same over here. Cool. Okay. So now if I do git log, you can see that where my repository is currently is called the head. Okay, that's just some new information for you. And where the repository is currently pointing is the latest commit in my branch. Okay, but the latest commit in the master branch is this one, which is earlier in history. Okay, latest history shows up first. Okay, so now we've made a branch in history where both our master branch and our new branch share that first commit, but our new branch has a new commit that is missing from the master branch. Okay, does that make sense? No, I see hesitation over here. Okay, so if we go back to, can I pull up this thing? Maybe I should I'll find that next time I teach this class. So let me find a simpler visualization. That'll work. Look at that. Look at you. Good job, Microsoft. I still hate you, but yeah. Nope. Yep. So in this case, this G is that first commit that you see here, right? So like this is G in this image. There we go. Okay, so this one is like G, okay? And then we can have a history on the main branch, okay? We can have a history going here, but right now we only have history here on this F branch, okay? So that's this dot right here, okay? So I forgot where I was taking this. Where are my notes? Where are my notes? I'm lost without my notes. Where was I going with this? I can't read this, it's too small. Right, okay, so yeah. So we've made a new branch. We've made a commit there. So you saw the commits in the logs, okay? But now let's go back to our original branch. If your main branch is called main instead of master, you'll want to swap out master for main. But okay, I need to fix up my stuff a little bit. Okay, good enough, maybe. So I can do git check. Wrong window. Git checkout master will put me back on the master branch. Okay. And now if I do git log, you'll see yeah, okay, no, sorry. I was confused because there we go. Much better. Okay. You only see this first commit. Okay, because that second commit was on a different branch. The master history does not know about that commit on that other branch. Okay, it's a different path of history. Okay. So let's do that over here too. Okay, same thing. Okay. So, does that make sense so far with the different histories? Cool. If you understand that part, you're doing pretty good because a lot of people have trouble understanding different paths of history with Git at the beginning. Also, if you kind of think you understand it, but you're not very solid about it, don't worry too much. It'll become more natural with time and practice, okay? And of course, if you have questions in the future, you can always ask us on Discord. But yeah, so let's, yeah, so we check the log. We notice that, that second commit is missing because that commit was on a different branch, okay? Now, what if, let's say we've done a whole bunch of work on that other branch and we're happy with that work. That work is good. We want that work to re-enter the main history, all right, and become part of our main branch, okay? This is a normal process. You'll do this all the time in real software projects. What we want to do is we want to take that alternate history from that branch and we say merge it back into our main history, okay? The term for this is merge. The command is actually merge. So once you're back on your main branch or your master branch, whichever yours is called, I should really update my Git. You can say git merge and then the name of that branch. So in my case, I called it my branch. So if we do that, you'll see it says, updating these two Git commits. It's just going to fast forward because there wasn't any conflicts. It just saw a new history with nothing here, so it's just going to go like that. One file changed, one insertion. Okay, so now if we do a git log, you'll see that both master and my branch are at the same commit history because we have taken the history from my branch and merged it into the master branch's history. Does that make sense for everyone? Question was, do we have to be on the main branch when we merge? You want to be on the branch that you're merging the other history into. So yes, you can merge to other branches. So there are different strategies of managing Git histories. Like there's Git flow, there's GitHub flow, there's all these different methods of doing things. They'll actually have like a main branch and a develop branch and like a release branch and then feature branches, and they'll be merging back and forth between whichever ones. It's very common. So yeah, good question. Other questions? Cool. So now, like I said, this will take all the commits from my branch and incorporate them into your main history again. Now here's the thing. Let's say that I made some chances on my main branch and I made some changes on my other branch, and those changes are conflicting. okay? That will happen very often. It is not fun, but it's also not terrible. That will create a conflict. And Git will say, hey, there's a conflict and I'm not smart enough to fix this for you. Please fix it. And then you can fix it and then you can merge, okay? So you don't have to type this part out because I'm going to go fast just to demonstrate, but I want to demonstrate a conflict so you can see what it looks like and how to handle it. Because a lot of times when people see their first merge conflict, they panic and then they don't know what to do. I don't want you to panic, okay? So you don't have to follow along. I am going to go fast, but I want you to observe what happens, okay? I'm just going to do this on the Linux side because I like Linux. So let me just, I'm going to edit, I'm on, which branch am I on? I'm on master. Okay, so I'm going to edit my file. I'm going to say, this is new master history, okay? And I'm going to save that, and I'm going to commit. Added to master history. Whoops, master history for conflict demonstration. Okay, and then I'm going to check out my branch. Okay, or first, git log. You can see here's this, added to master history for conflict demonstration. So far, so good. Now I'm going to check out my other branch. Check out my branch. Okay, now I'm going to edit that same file, except in this line I'm going to say new history in my branch. Okay, so I've made conflicting changes to the same file in two different branches. Okay. Okay, so you can see demonstrating conflict in secondary branch. Because I made that other commit on the master branch, you don't see that commit here. Okay, remember, we have divergent histories now. Okay, you know what, there is actually a way to visualize the history graph, and I apologize, I didn't figure out how to do that before this event. If I do this again in the future and record it in the future, I'll do that, but I'm sorry, I didn't prepare it this time. But anyway, you can imagine like we have a linear history and now it's diverged, and we have two commits in two different places. Okay. So now what I'm going to do, I'm going to go back to my main, or my master branch, okay? And I'm going to merge my branch. Okay, there is a conflict. Git will fail to merge this. Okay, so trying to auto merge conflict in the content. Merge conflict in myfile.txt. Automatic merge failed. Please fix the conflicts and then commit the result. Okay, so now if I do git status, it tells me there's unmerged paths, okay? Fix conflicts and run git commit, okay? Both versions of this file have been modified, okay? This will happen. This is normal. Do not panic. Everything is going to be okay. So now, when I'm going to open up this file again, okay? And you see this, okay? Fortunately, this is a small file. This is very easy to see. Sometimes in larger files, it's much harder to see this, okay? Most people, when they're managing conflicts, they use some kind of development environment like Visual Studio Code or some JetBrains product or something. But in case you're doing it on command line like this is what it looks like. Okay, so this is the head, which is where my Git currently is. Remember, I was on master and then I was trying to merge this stuff into master. So head is my master branch in this case, because head is where I was. And then this is my branch, okay? This content is what's in that other branch. This is what's in my current branch, okay? And so Git recognizes these arrows and these equals and that kind of stuff. It recognizes that these are a conflict, okay? Git added these and is like, okay, I know that means there's a conflict, so I'm not gonna let the user, merge these until they get rid of those. Because this is not valid code, right? So you wanna fix this. So in this case, so when this happens, you have to decide which version is correct, or if you want to combine them and how to combine them. That's on you. That's normal software development. That's not a thing we're going to cover in Git because I don't know what kind of stuff you're building. Okay. So in this case, I'm going to decide I want both of these lines to exist in the file. Okay, I want them both to exist. I'm not going to modify them any other way. So I'm going to delete this line. I'm going to delete this line. I'm going to delete this line. This is the final state that I want this file to be in. Okay, so I'm going to save this. Git doesn't know anything yet because, again, Git only knows stuff when you hit add. So we're going to add. Okay, and now it says all conflicts are fixed because we removed all that conflict text. Okay, so Git recognizes that. But you're still merging, right? You haven't committed yet. So now I'm going to do git commit. I'm not going to add a message because when you do a more complex merge like this, Git automatically writes a commit message for you. Okay. Now you may not want to use that commit message. You may want to write your own, but I just want you to see what message it creates. So it creates, oh geez, I should fix up my thing. So it creates this message, merge branch my branch, right? That's the commit message that Git decided automatically. Okay. And that's saying that we merged my branch into master. Okay. It's not a great commit message. You may want to write your own, but I just wanted to demonstrate. Okay. All good. So now we accept that commit info and the branch has been merged. If we do a git log, now we see that the history from my branch is now included in our master's history. Okay, because we're on master and we did a git log. So now, because we merged, we see this history of my branch. And then we see this merge commit that we made. Okay, does it make sense? I see some gears spinning for some people. So remember, this commit originally, here, let me do this on the Windows side. Okay, wait a second. I don't remember what I was doing. Also, this is weird. My author info is messed up. I'll fix it later. Yeah, I don't know what's going on there. Anyway, this commit was on the secondary branch, the my branch, okay? But because I merged my branch into main branch, now that history is also in main branch because I did a merge, right? Just like we did a few minutes ago, okay? So that's why it shows up here. And then this merge commit is representing that there was a conflict and that we fixed the conflict and merged stuff together, okay? So that's all we got. Because resolving the conflict, making those changes to a file was still a change. So we need a commit to represent that change. Okay, all good? This part's a little less important. If you don't 100% understand it, you're okay. All right. If you do have questions afterwards, we can talk. All right, so in any case, that's how you do a merge. So you just, on the branch that you want to merge history into, you go to that branch and then you say git merge, whatever branch you want to merge into, or want to merge, whichever branch's history you want to merge into your current branch. Yeah. So now, for your own sanity, I recommend that if you have merged a branch and you are not going to continue working on that branch, remember to delete the branch. Otherwise, you're going to end up having like 100 branches and you're going to be like, wait, I have to scroll through all these to figure out which branch is the one I want to look at. So to do that, you can do the git branch command and then -d for delete, and then the branch you want to delete. So let's do that real quick. You can do that locally too. Let's work together again. Mm. Yep. Yes. Thank you, Jay. So for folks online, Jay brought up, hey, if you're having trouble remembering like all this -b, -d, all this kind of stuff, you can do -h for help, or you can do --help. I do --help because I type fast, I guess. I don't know. So you can do git --help, or yeah, git branch --help. Yeah, you don't want to do it for just git. And it'll show you all the stuff that's possible. Okay, now reading through this is a bit of an art in and of itself, but this provides all the information you need so you can scroll around and you can say, wait, here's -D. Okay, that's delete. Okay, so that's a nice little helper. Thank you, Jay. So let's go ahead and delete my branch because we don't need it anymore. So git, again, if you're not on master, make sure to git checkout master or main, maybe, to get back to your main branch because you don't want to delete the branch you're on. I don't think git allows you to do that. So let's do git branch D. One second, I got a message here. So someone was asking online, is there a hangout today after the workshop? We always go for chicken or some kind of food after the event. It's obviously not mandatory. I can't make you stay here. But if you want to grab food afterwards, we're going to do that. CodeSoul does pay for it. It's free food. You should eat. But anyway, back to this. Right. So git branch D and then my branch. And you'll see deleted my branch. So if I do git branch now, you'll see that my branch is gone. So the question is there any, I'm just repeating it for online. Is there any way to restore a deleted branch? You can do it on GitHub. I don't actually know if you can do it locally. I've never tried to. I'm usually quite careful about deleting branches. Like I don't delete branches unless I have merged them. And usually I do it like right after merging them. So I don't know. Maybe, but does anyone, Jay maybe, or other experienced folks? Yeah, I've never needed to. But yeah, good question. Sorry that I don't have an answer for you. Maybe someone can Google it and share. Um, okay. Did I delete it here? I don't think I did. Okay. So, and again, we can see the branch has been deleted. Okay. So far, so good. Everyone cleaned up their unnecessary branch. Cool. All right. So you're good on branches. Good job. That's probably the hardest part, and you did it. So it gets easier from here. All right. So let's say that you've been developing your software. You have a crazy long commit history, and you're like, it is la time. It is time. So I don't know why I went French there. I'm referencing really, really old memes. I'm sorry. It's time to release our software. And I want to say this is the commit that we released to the public. Okay, this is the state of the software. This is a snapshot in time of the state of the software that we released. And that's an excellent use case to use a tag, especially because if you have cool DevOps engineers, or maybe you become a cool DevOps engineer yourself, you can do all sorts of automation in response to tags. Like you can automatically deploy when a tag has been pushed. But we're not covering that today, but at least you know it's possible. So we can mark this release as special by giving it a tag. Okay, the subcommand is tag, and then -a is basically adding the tag name to the commit, and then -m for a more detailed message. Okay, so let's go ahead and tag your current release, or your release, tag your current commit. Okay, so let's go ahead and do that. So I'm going to do something like git tag 1.0.0, and then first release, which is a terrible commit message, or a terrible tag message, but whatever. This is a tutorial. Okay, and let me do it on both Windows and Linux. I don't, you know what, maybe doing both Windows and Linux wasn't necessary, but safety nets. Okay, so again, we see no output. The Linux philosophy, that means everything's cool. It was quiet. But now if you do a git log, you will see tag 1.0.0. There we go. That's it. It's just a label applied to the commit. That's really all it is. All good? Everyone can see their tag in the Git log? Cool. I think, I haven't tried this. We're going off my planned path, but let me check something real quick. Yeah, so if you do git tag -l, you can list your tags. Okay, that's not helpful. Sorry, I don't remember how to show the detailed info. Is there like a verbose? No. Long? No. Well, yep, that's what I get for trying to go away from my original plan. That sucks. Anyway, so yeah, that's how you can give tags, and on things like GitHub, you'll actually see these tags in the UI along with the message that you provide and all that kind of stuff. I don't remember how to show the message on the command line. You can Google it if you need it, but chances are you're not going to need it. All right. So everyone's good on tags? Oh, we were going to try, Sun. Oh, what's up? Oh, okay. If you change your mind, feel free to interrupt me. So San had the question of, can we apply the same tag in multiple places? And we have time, so let's try that. And I'm also going to show you something funky. So remember how I said that, Git gives you safety that you can like check things through time? We're going to do some crazy stuff. So let's say that I want to look at a previous commit. I want to see the state of the repository during that commit. Because what's the point of having history if you can't go look at the history, right? Or look at the state of things at that point in time. I'm going to copy this commit hash from the log, okay? And I'm going to do git checkout. Remember I said checkout can do a whole bunch of stuff. I'm going to paste that commit hash. And now, you see it's going to give me a warning that I'm in a detached head, okay? Which means that I'm not at the latest point in history to create new history. I'm in kind of a weird state. But anyway, I have switched the repository back to how it was at that point in time. Okay, I've gone back in time. And to test Sun's question here, I'm going to try applying a tag to this. You don't have to follow along. I just want to check to get an answer for your question. So I'm going to try to apply that same tag. I think the message doesn't matter. The tag's the important part. I'm pretty sure this is not going to work, but we're going to find out. Yes, it's fatal error. That tag already exists. So you cannot apply the same tag to multiple commits, which logically makes a lot of sense. Okay. So then let's say that, so if I do get status, it'll warn me like I'm in a detached head at some random commit, because like Git does not like that, because then you're really messing with history in a way that you shouldn't be. If I want to get back, I could just do git checkout head, and now, oh no, git checkout master. It's been a long time. I could just check out the branch again, and now I'm back to my proper head. And if I do git log, I'm back to where I was. Okay. So does that answer your question, Con? Or Con? San? Sorry. Con is one of my coworkers. Yeah. Cool. All right. Any other questions about tags? One commit can have multiple tags, yes. So I can do git tag A, the best tag. It's better than the other one. And that's fine. Oh, not a valid tag name. Right. No spaces. No spaces. No spaces. Okay. You can see it has two tags now. Good question. There's not really, I can't think of a good reason to give two tags to the same commit. There probably is in some workflow, but I have not seen it done. But it's possible. Any other questions about tags or branches or any of that? Yes, you can check out by tag. So if I check out that old commit again, and I do, so now I'm in a weird detached head. Basically, I'm somewhere that's not the tag right now. If I do git checkout 1.0.0, works fine. Yep. So when you do git checkout, it searches a whole bunch of stuff. It searches commit hashes, it searches branches, it searches tags, and whichever thing it matches, it just goes there. So in this case, it found a tag, it looked up the commit for that tag, and then it switched to that commit. Does that answer your question? Cool. Other questions about tags or branches? Yes. Sorry, one more time? Why can't I delete my current branch? Because there's a few. I mean, I'm not the creator of Git. I'm not Linus Torvalds. I can think of a few reasons. One is if you delete your current branch, what branch do you go to? Right? Git wouldn't know where to send you, and you have to be on some branch. The repository has to exist in some state. So I think that's probably the most practical reason. Actually, maybe that's the only reason. That's a good point. So for the benefit of online, Jay also mentioned in the case where there's only one branch and then you try to delete that branch, well, if a branch is where some history is stored and stores the state of the repository and you delete the only branch, what is the repository? So yeah, does that answer your question? Cool. Other questions? Yes. So the question was, are all branches equal? In like pure Git, yes, all branches are equal. You can rename the master branch to whatever you want. And that's actually GitHub recommends that when you're setting up for the first time. We're getting tight on time now. Yeah, but practically main or master is the trunk, is where the main history is. But Git doesn't really care what branch is what. Now in GitHub, there is a thing where you can apply protection to certain branches, which does give them some kind of hierarchy sort of thing going on. But that's a GitHub thing, not a Git thing. Does that answer your question? Cool. All right, so I would ask for more questions, but we're getting real tight on time. We got 10 minutes left to do the GitHub side of things, but it's actually not too hard. So let's get to it. So what is GitHub? So first off, congratulations, you understand the basics of Git, right? Now there's a whole lot more. There's like a lot more, but this is like the absolute minimum to be useful, okay? And I do have a reference for other stuff that you can learn independently. But going on to GitHub, what is GitHub? A big thing is that it's safe online storage where you can have a proper backed up version of your software. Another big thing is it's collaborative. It makes it really, really, really easy to work together. And it can also serve as a portfolio. If you make your repositories public, other people can see them and they can see what kind of code you've written. Hint, it's a good idea to put your GitHub on your resume. Hint, hint, nudge, nudge, wink, wink. As a hiring manager, that's like the first thing I check, by the way. Yeah, now that said, GitHub is not the only online Git service. There are also GitLab, which I actually like a lot, and Bitbucket, which is Atlassian's product. And there's also SourceForge, I think, still uses Git, but SourceForge is a little less popular these days. But there are alternatives, but GitHub is the most popular. I think, did Google Code die? I don't remember. No, it's still alive? Okay, there's also Google Code, which is another thing like that. But yeah, so that's GitHub. So let's go ahead and try doing some GitHub stuff. So let's make our first repository. So let's go to the GitHub website. So go to github.com. we're going to do this together, but I'll just describe the steps first. We're going to click the big green button to make a repository. Then we will fill in the info for the repository. Then we'll click the next big green button to actually make the repository itself. And then it gives you a whole bunch of directions to set up your repository. Okay, so let's go ahead and do that. So I'm going to go to GitHub. All right, so I'm logged in already. Okay, please go to GitHub and log in if you are not already. All right, we're going to do this together if you want to. And I'm going to click the big green create new repository button. Oh, what sound was, why did I choose to make that sound? Anyway, now there's a whole bunch of stuff here. Okay, I'm going to make one for Code Soul because we have an organization. And I'm going to do 2023 intro Git. Okay, and description, this was our 2023 Q2 intro to Git example repository. I don't know if I typed that right. Repository. And I'm going to make this a public repository. And now here's the thing. If you already have a repository on your local system, don't add a README, don't add a git ignore, don't choose a license, because then you're going to have conflicting histories and it's going to be a giant pain in the rear end. If you do not have a local repository already made and you're starting from GitHub, then go ahead and do this stuff. A README is just kind of introducing the project and shows up on the main page of the project. A .git ignore file tells Git which files to ignore. So for example, let's say you have a file that stores your secrets for your application to run, like API keys or passwords. You should record those in your Git ignore so you do not accidentally commit those and make those public. Don't do that. It is bad. And then a license is like, the legal side of things, like can my code be copied, or under what terms can others copy my code? Okay. Now in this case, we already have, we're gonna upload the repository we've already made. Okay, so we don't want any of that stuff. All right. So now we can click create repository and go ahead and do that. I gotta get rid of that plugin. Okay, and now you see the blank repository page. Okay. It is wonderful because it gives you instructions. Okay, so if you're creating a new repository, you would follow these steps. Okay, this assumes that you're on, actually no, because that works on Windows now. But in this case, we're going to do this one, okay, because the repository already exists. So remember I talked about remotes, where remotes are other copies of the same repository that you can link. What this command does is it actually adds GitHub as a remote of your current repository. Then it renames our branch to main in case our branch is named master, which is great. And then we push our local copy of that branch, our local history on that branch, to GitHub. And then they're synced. Okay, so let's go ahead and do that. You can just straight up copy these. Or I'm actually only going to do it for one of these, otherwise we're going to have a terrible, terrible time. So I like Linux. Let's do that. So yes, please, paste anyway. What? Hold up, what? What did I do? Okay, so my remote is added. Git branch m main. Huh. I think I need to update my Git. Okay, we're going to do this on Windows. You shouldn't run into that. I think that's something weird about my system. Oh, damn it. I do. The problem is that GitHub changed their identity keys. Yeah. Do I have Vim on Windows? Of course not. Sorry, give me a second. Well, it's no, it's not my key. It's GitHub's known host key. Yeah. You won't run into this. This is a me problem, not a you problem. Yes. Yes. So this is like, you're not going to run into this. When you do your push, it's going to ask you to log in. So you can just type in your login stuff. It's totally safe. I'm using SSH-based stuff. That's more advanced. We're not covering that today, so I had to go fix a bunch of stuff because GitHub changed their stuff, and then I haven't used Git on this computer. You don't got to worry about it, okay? But anyway, you should see this part onward, okay? So enumerating objects, which includes commits and tags, and I think branches too. And then, it does compression for purposes of sending over the internet. It writes the changes to the remote, and then it shows, hey, we made a new branch, main. So now if we go back to GitHub and we refresh, there's my file.txt. Okay, has everyone gotten to this point? Your copying and pasting should have gone way smoother than mine. All right, now we're a little tight on time, but we're going to go for it. Let's go back to, not this, not that. There we go. All right, so everyone got that far? They have their repository up? Good job. All right, now, let's go ahead and make our first PR. I'm sorry, we're gonna go like 5 minutes over time. So what is a PR? A PR is short for pull request. Where are my notes? My lovely notes, please. Okay. And a pull request is when you request the owner of the repository to basically pull your changes into their repository. Okay. It can be from between branches within the same repository, or it can be between different repositories. Now, those of you who understand the history stuff a little bit well, you might be thinking, wait a second. If a repository is a set of history, and you're trying to merge changes from one repository into another, but they have different histories, how is that supposed to work? And that is the right thought. It doesn't work. You have to have a shared history, otherwise it won't know how to merge stuff. So when that happens, or if you want to basically make a change to someone else's code, you need to copy their repository, okay? To do that, on GitHub, we call that a fork. So you fork their repository, it makes a copy of their repository with all of their history, and makes a copy in your account on GitHub, okay? And then, now, forks are not a Git thing. They are specific to these online Git services. I think GitLab also calls them forks. I'm not 100% sure. But it's basically just copying someone else's repository to your account. So basically, once you've made a fork, you have a shared history, you can make changes, and then you can request them to pull your changes into their repository. All good? Cool. Now, great, but how do we submit a PR? How do we create a PR? Well, I'm glad you asked. Let's do it. So, if everyone could for a moment go to GitHub and go to, let me do this. Go to github.com/codesol. Whoops, wrong window. Go to github.com/codesol /2023-intro-git. So please go to that in your browser. Maybe I can write it a little bigger. Ah. Okay, so I'll give everyone a moment to type all that out. All right, so now, once you have done that, you can, oh, I need to fix this. Oh God, let me just mess up the stream here. There we go. just moving the thing. So once you've done that, go ahead and click this fork button here. What this will do is it will first off ask you where you want to do it and what you want to call it. And I'm going to say create for. I'm cool with all these settings. What it's going to do is it's going to copy the repository to my account. Okay. Remember how I said you need the shared history and all that. So now it's forking, and now notice it says here, instead of code sol slash 2023 intro git, it says the Beege. This is my personal account slash 2023 intro git. And then it notes that, hey, it's forked from that repository. Okay. So if you've done that, so far so good. Okay. But now you want to make a change to this and you want to submit it back, right? So what you can do is you can click this code button here and you'll get this kind of thing. Okay. You want to click this button, all right, to copy it. I'm going to do this one because I'm doing SSH things. And then you can I'm teaching you a new command now, clone. Clone, I can type, and then paste that thing you copied, okay? Now, once you've done that, sorry, don't do it yet. You want to go up one folder, okay? So cd space ... okay? Otherwise, you're going to close the repository inside your repository, and you're not going to have a good time. So go back up one folder. Oh no, I used the same name. Oh, mistakes were made. Okay. Right. We're going to do git clone. Oh, this is Windows. Okay. We're going to paste. And then normally you just do git clone and then you put the URL. And then it takes the name of the repository and makes a folder with that. But I messed up. We already have a folder with that name. And Git's not going to like that. It does accept another argument where you can say what you want the name to be. So we can say code sol intro git, okay? And now, and I need to say yes because of SSH things, but now it's cloning this repository, but it's putting it into a folder of a different name called code sol intro git, okay? So once you've done that, cd code sol intro git, and now you should have a copy of my repository that I made on the Code Sol organization on your computer and linked to your account. So, or let me just, so the, oh, this is Windows, okay. So you can see this myfile.txt here, okay? So if you've done that, go ahead and let's do, yeah, let's do it that way. So if you're on Windows, I'm gonna give you a cool little pro tip. You can do Explorer and then space dot will open up an Explorer window in that directory. Okay, so that's a thing. If you're on Finder, I'm sorry, if you're on Mac, you can just do open space dot, and that'll open up a Finder window. Okay. And then what I would like you to do, if you are following along on this part, is make a new file. And say, call it like your name or something, or whatever you want to be called if you don't want to put your name online. So I'll just say beege.txt, and I'll just add a message like hello from Beege. Okay, save that. I thought I hit save. Okay, whatever. Save. What are you doing? What? Just save the file. Why are you asking me to save it in? Oh my god. Wait a second. No, this is, what the hell is going on here? What is this nonsense? Wait, what? What? Oh yeah. Oh, this is the other one I had open. Sorry. Okay. There we go. Cool. All right. It's because I had multiple notepad windows open. Sorry. All right. So now git status, git add beege.txt, git commit, added my name. And then because we cloned, the remote connection is already set up. Okay. So now you can just do git push. and it'll take all of your commits that exist on your local that don't exist on the remote, and it'll just copy them to the remote. So, bam. Oh, stupid SSH. Why? I just commit, you should have remember. Whatever. Okay, so now I pushed, and if I go to my repository, you'll see here, there's beege.txt, okay? So hopefully you've done that on yours. I'm sorry we're going over, we're almost done. So you've forked the CodeSol repository, you've made changes on your local copy. Now let's submit a pull request to the CodeSol repository to merge your changes into the organization version of the project. So let's go to pull requests. Okay, so I'm going to click this here on the repository page, pull requests. I'm going to click new pull request. And you'll see here I can choose the CodeSol source, and I want to merge my main branch into their main branch. And this is the only change between them. Okay? So once you've done this, you can click create pull request. You can give a message. I want to immortalize my name in your repository. Okay? You can do whatever you want here, it doesn't matter. And create pull request. Sorry, Alex, I'm running behind. We're almost done. And then now because I'm an admin on CodeSol, I have the ability to merge here. But if you submit a pull request right now, I will merge it. Okay? And if you don't, that's fine too. I only expect like 1 or 2 people. But go ahead and submit a pull request, and I will merge it. And then you can have your first pull request merged, which would be really cool. Let's see if anyone else submitted a pull request. Oh, we did! All right, son. Wait, I have to review it. Good. Let's get this merged. Wait, no, let's get this merged. And then merge pull request. Do it. All right. So there we go. The thumbs up. All right, any other pull requests? Yeah, one is pretty good. Cool. All right, so that's it. If you submitted your first pull request, son, congratulations. Although maybe you've done it before, I don't know. If you're having trouble, catch up with me later. We can get you fixed up. We can help you get your first pull request. I don't see any other things on chat, so I think we're good. And let's go ahead and tie this off. So we talked about our first PR. I just want to mention some other stuff that we did not cover today. Okay, I mentioned in passing the git ignore file. You definitely want to learn how that works. It's not complicated. It'll just be 10 minutes of reading. And there's a whole bunch of other commands that you can learn. Some are more useful than others. For example, bisect you very, 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 very rarely use, but it's super cool. I'm not going to explain all the stuff now, though. But a lot of engineers don't even know all of these. They know like git ignore and pull, and maybe that's it. But if you want to be comfortable with Git, you can read about these. There's lots of good documentation, lots of good tutorials, because huge numbers of people use Git. Okay? But we're not covering this today. But here's a reference for you to go Google stuff. So good job. Thank you for following along. I know it got a little rough at the end there, but everyone did a really good job following. This is the smoothest that we've done this class, and we've done it like 5 or 6 times. So today we covered what is source control, what's Git. We went over the concepts of Git, like repositories, branches, commits, and tags. We went through and made your first repository, and you made your first commit. We went ahead and messed around with branches a bit, and we did some merging. We learned some new things about tags. And then we went on GitHub, set up your first repository, and potentially made your first PR. So thank you for following along. I hope that wasn't too difficult. I have a list of additional resources if you want to go through other tutorials. Okay, so make sure if you want to grab these, you can join our Discord and find them. I've also linked the live stream video in here if you want to reference that as well, but that is also on the Discord. So thank you. Where's the thing? Okay, I must have used an old version of the presentation. Anyway, um, there's supposed to be a QR code there for the Discord, but you can email me. I don't check it terribly often. I check the Discord more often, so do check the Discord. It's linked in the event info. If you want to donate, you can donate at there. We are not tax deductible yet, but we're working on it. We're talking with lawyers to, because like Korea does like a weird tier system where you start out as just like, oh, I'm a nonprofit, but I don't get any benefits of a nonprofit, and then you have to go to the next level. That's what we're doing right now. We have to pay $3,000, and it sucks, but that's fine. But anyway, we hope to become tax deductible in the coming months. I'll let you know when that happens. So if you donate now, it's just out of the kindness of your heart. We don't expect anything. What's up? No, no, no. That's just to get registered. Yeah, yeah. So it's not. It's just, and I shouldn't have mentioned it. I'm not trying to like persuade. Like, it's only if you want to. We're fine. We have the money for it. But yeah. But anyway, after this, we're gonna get some food if you want to join. If not, that's cool too. But thank you everyone for coming and for spending your Saturday evening with us. We hope you had a good time. Again, if you have questions or troubles, you can message us on Discord. And thank you again. Bye, internet.